when this exhibit was when I heard about being developed, I thought, oh, it's just going to be for kids. It's just very basic weather information. And I was being negative, and it was stupid of me because this exhibit really is really informative. It's lots of fun. And as Maurice mentioned, it gives basics in weather information and then carries it further to the extreme weather phenomena that is the heart of the show. And we certainly are, as time goes on, experiencing these weather events more frequently. A lot of people who are weather or climate change deniers are thinking in very short-term time frames. And these changes we have seen in the last 50 years. Bird migrations changing, glaciers melting, and look at pictures of glaciers on top of mountains, Mount Kilimanjaro in South America, in the States, from even the 1920s, and then see pictures of those glaciers now, and they're almost unrecognizable. So we, in a relatively short period of time, have seen these changes. The Earth's gone through climate change since its beginnings more than 4.5 billion years ago. We've been kind of used to a relatively mild, relatively speaking, climate over the last 50 or 60 years. But things are changing, and the climate models that have been created by scientists certainly don't, if you take out human influences, those climate models don't match the temperature changes that we are now experiencing and noticing overall the Earth. But when you put the natural variations in temperature with the human aspect, it's called anthropogenic, human started, then they match. And that's kind of creepy. In a way, it sort of is a thumbs up for the science, but it also means that we, over the past 250 years, since coal started to be burned in the Industrial Revolution, have really started to change things. I wasn't planning on saying all that, but here I am. All right. So, I'm going to start with George, if I may.
Please. Please do.
Okay, I will. Not just because he's a television star, but just because I want to ask him this question. You've been chasing storms as well as exploring other violent phenomena around the world. What are some of the most severe weather phenomena that you have experienced?
That I've personally witnessed. Where do I begin? Well, 20 years of storm chasing, in about, not just chasing storms, but I document all extreme forces of nature, from tornadoes, hurricanes, avalanches, erupting volcanoes, diving with sharks, swimming with piranhas, basically any way that Mother Nature wants to kill you, I've been there with a camera rolling. Still in one piece. Never spent a night in hospital, not even broken a bone. So my mother has gray hairs, but yes. As far as hurricanes, the strongest hurricane I've ever encountered was Hurricane Katrina. I was in Gulfport, Mississippi during that storm when it came ashore. It was the costliest natural disaster in U.S. history. Estimates between $70 to $100 billion worth of damage, and I was in a steel-reinforced concrete parking garage as the entire town of Gulfport, Mississippi was coming apart. The strong side of Hurricane Katrina hit Mississippi. The weak side hit New Orleans. And the storm weakened before it made landfall. So if it had hit a little bit more to the west and held its strength, the damage in New Orleans would have been 10 times as bad. So worst case scenario for them, not even close. It could be much, much worse. As far as tornadoes, the largest tornado I've ever witnessed was the world record holding tornado in El Reno, Oklahoma a couple of years ago. 4.3 kilometers wide. Get in your car, put it in drive for 4.3 kilometers. That's how wide this thing was. It looked like a smudge on the landscape. So there's two examples of storms that have been extreme, but I've been in volcanoes where I've had to dodge pieces of lava flying overhead and things like that.
Was Katrina stronger than the one that devastated Galveston in 1900, or do we know how strong
the
that one was?
Galveston, it's interesting. I was in Hurricane Ike in 2008, which also hit Galveston right on. I was in the eye, the calm eye in Galveston, and I was watching the waves crashing over the memorial for the 1900 hurricane.
Okay.
And that one was very bad, but I don't know how strong it was. The records back then aren't as good. They didn't have the radar and satellite imagery that we have now.
Okay.
But it was devastating.
One more question for you right now. When you're in your tornado chase vehicle, or a tornado chase vehicle,
Yes.
and you're as close as you have gotten to the center of the tornado or whatever.
I like to get close enough that I can hear it.
Yeah.
They sound like a waterfall. People say they sound like a freight train. They actually sound more like a waterfall.
Yeah.
And continue.
So, I mean, how much is that vehicle moving?
The tornado is the part that you see. It's the wind that's around it is also part of the tornado. A tornado, by definition, is a violently rotating column of air that's in contact with the ground. Not necessarily that funnel cloud or the dust. It's the air. So that air can actually be wider than what you visually see. So I've had instances where I can see the tornado, I'm pulled over on the side of the road, I open my car door, and everything that's in the car gets sucked out. GPS, maps, everything, just gone. I had to go back the next day. I had to go searching through the cornfield to find this stuff. A couple of years ago, I was in Nebraska, and a tornado formed right beside us, almost on top of us. You could barely see it, but one of these irrigation systems, this farmer's irrigation system for watering his crops, got pushed by the tornado right into our windshield and smashed the windshield while I'm driving down this farmer's road. So yeah, you get blown around a lot.
Is the debris that you see when that makes all that air visible, when you're in their vehicle, is that debris making a lot of noise as it smishes into your...
I try not to get that close, but yeah. It's not... The thing with a tornado, it's not that the wind is blowing, it's what the wind is blowing, right? A brick or someone's cat can hit you and it's going to hurt, right? Or a car or a barn, right? These are very powerful winds. When winds get that high, they start behaving more like a solid, and that can cause you a lot of harm.
Yeah. Okay, thanks. All right, Mr. Engineer. In places that experience these extreme weather events, like hurricanes, what changes have happened recently? What engineering improvements, or whatever? What do you do to make the buildings safer or more resistant to harm, or falling down, or falling apart, or whatever?
Well, there's quite a few things you can do. It's easier than you think and cheaper than you think. So in Miami and South Florida, they've been hit by massive hurricanes, and they had problems. Hurricane Andrew before Katrina was, I guess, the most damaging. And one of the big problems there was all the sheathing came off people's roofs. Why did it come off? Well, they'd introduced gun nailers for the roof sheathing, and none of the nails hit the trusses, so none of the sheathing was actually nailed onto the roof. So all the roof sheathing blows off, the trusses fall, your house fills with rainwater, and you have a complete write-off. And so it's about getting the nails in the right place. When you make your deck in the backyard and you fix it, you go buy screws, you don't buy nails. And there's actually engineered nails now that have the threads of screws. And if you put that in your house, it costs about the same as a case of beer in terms of the difference. And that will make your roof a lot stronger. So it's about little things. The debris is crazy, and storm shutters and things for that help. That's more expensive. But even if you do these things for hurricanes, we think you can even make houses survive EF2 tornadoes. And 90% of all tornadoes are EF2 or less. And so we think we can mitigate that.
Is there anything that you could really do to mitigate, say, an F4 tornado? I'm not even going to go to F5, but an F4 tornado. I mean, in our little simulation over there, you can point your iPad at the building. You folks will try it. It's quite neat.
Very cool, actually.
There's sort of a model of part of a little town, and you can point this screen, it's an iPad, I think, at parts of this little town, and then push F3, F4, or F5 and see what the damage is. Don't worry, I'm not giving it away. It's really neat. So is there anything that you could do to really make a super difference with an F4 tornado?
You could, but it's a bunker, and people don't want to live in a bunker. So for EF4, what you should be doing is building a storm shelter in the house. And that costs a few $1,000s. But you can build a storm shelters. There's design guidance now for EF5 tornadoes. For you to survive the tornado in your house, there's shelters for that. And
that's for you to survive, not for your home to survive.
And there's photographs of them afterwards. The houses are gone, and the storm shelter is literally just sitting there, and people walk out.
Well, we saw, I mean, anybody who's seen The Wizard of Oz knows that the tornado's coming, and Auntie M and everybody else heads into the thing except for Dorothy, and bad things happen. So, well, maybe good things.
The good thing in Canada is we have basements. And the EF5 in Ely, Manitoba, 7 or 8 years ago, there was a family that survived. They went to their basement, they hid under a mattress, and apparently they got lifted up about a foot or two as the house, and after it was all quiet, they looked up and their house was gone. They saw blue sky, but they were safe in their basement.
And the mattress survived,
yes. The mattress survived. No one was killed. That's what we want.
Yeah, that's true. That's true. You can't rebuild people.
You could build a house that is fortified for those type of winds, but it would be ugly.
It would be ugly.
Yeah.
And expensive.
Nuclear reactors.
Yeah.
They're designed for EF5. Their design impact is a Volkswagen Beetle flying through the air and hitting it, and they have to survive that.
Yeah.
But you don't want to pay for that with your house.
Who's paying for that?
Exactly.
Yeah. Although I'd like to see the testing. That would be fun.
that would be cool.
I know.
Yeah, can we rig that up? Can we get like some kind of air cannon that shoots a Volkswagen at things?
Yeah. Well, you mentioned
the next exhibit.
You mentioned.
Yeah. See, that's a new. I'm going to do that for my show.
You mentioned the trebuchet. We could. They had one at U of T a few years ago.
You guys engineer it. Yeah. We'll do it. I'll film it, and we'll do it here at the Science Center.
That's what partnerships are all about.
Science.
That's science, folks.
All right. All of us, all of you. Climate change. Now, we've, when I was rambling on at the beginning, I was talking about climate change, and Maurice mentioned climate change being a real thing rather than what 40% of the people may be believing, and maybe fewer in some other places that we won't mention. Have you noticed, we've talked a little bit about this, have you noticed in your own experience good evidence of the climate change stuff? Because you've been chasing tornadoes for a long time and hurricanes.
Yeah, geez, I've seen so much. It's not so much in the storms that I've seen, because the difference between weather and climate is what you expect, weather is what you get. Right? So we expect a certain number of rainy days per year. What we get is the weather, and those fluctuations in weather over a long period of time is your climate, right? So from storm to storm, it's really hard to put your thumb on it and say that storm was enhanced by climate change, or this tornado was stronger because of climate change. Perhaps, but it's very hard to prove that. But at the same time, I have seen wildfires that you would not believe. I have seen swings in temperature. I have seen these glaciers that you refer to disappearing. I've been in Antarctica and the Arctic watching huge icebergs calve off of these glaciers at unprecedented speed. Things like that. Mm-hmm. It's the cumulative effect of 1 year warmer after the next, after the next, after the next. So we will likely see more of these extreme events and storms, but it's really hard to put your thumb on it and say that one event was caused by it.
And also, we hear often more extreme weather. Every time people talk about climate change, it's more extreme weather. But the problem with that is the emphasis in that statement. It's not more extreme weather, it's more extreme weather. So you can have, say, 12 hurricanes on average in the Atlantic over a 30-40 year period. And that will stay pretty much the same, or it will actually get a little bit less as climate change continues to affect us. The problem is that in that grouping, at average, there's a sort of, you've got the weak, and you've got the moderate, and you've got the extreme. And what climate change is doing is it's taking that spread and pushing it towards the extreme. So you're leaving behind all the weaker ones, and you're having more moderate and more extreme ones. That's the more extreme weather. So basically what's happening is that you're putting all this energy into the system, into the atmosphere, via more carbon dioxide, higher temperatures, and then that is having an effect of pushing these storms towards more extreme levels, but then you have sort of a weird counterintuitive thing where increases in wind speed counteract that for tornadoes and for hurricanes, because it's called wind shear. It's the difference in speed and direction of wind with height or with it between 2 points. If the wind shear is stronger, which is what we're expecting with climate change, you get weaker hurricanes on average. You get weaker tornadoes, or no tornadoes on average, or less tornadoes, because this wind shear cuts these storms off, doesn't let them develop as high as and as strong as they should. The problem is that weather isn't always constant. It's always changing, so you're always going to end up with conditions that combine together to give you hurricanes, to give you thunderstorms that will produce tornadoes. With more energy means those things will be stronger. That's just pushes it towards the extreme constantly. So remember that whenever anybody says more extreme weather, just remember that it's the extreme part that is the more. You're not getting more storms, because you hear a lot of climate deniers or contrarians or whatever you want to call them saying, oh, well, it's completely false that we're going to have more storms. Well, nobody said we were going to have more storms. We're going to have more extreme storms. So that's a good distinction for it.
Agreed.
Yeah, I think it was a big surprise, at least for New York, when Hurricane Sandy hit a few years ago. That was unusual. I mean, when Hurricane Hazel hit Toronto in 1954, that was a bit of a surprise, but it was just a hurricane doing something screwy, like heading out to sea and then heading back inland to land, where they generally weaken, but...
Well, interestingly, you bring up Hurricane Sandy. Everybody knows Hurricane Sandy, right? Massive storm, did tremendous damage in New Jersey and New York. One of the top 5 costliest hurricanes in U.S. history, right? Mm-hmm. It was barely a Category 1 storm. So it was huge, though. It was the largest, physically the largest hurricane recorded in the Atlantic, if I'm not mistaken. I believe it was the largest.
Yeah,
so you have that energy spread over a really wide area, and even though the energy isn't as strong, it's the difference between getting shot with a bullet or getting run over by a steamroller, right? One is going to do you in really quickly from something small, but you're just as dead. Maybe a little more flattened by one than the other, but the analogy sort of works. So Katrina was more of a bullet, Sandy was more of the steamroller, and it had to do a lot with the angle of the way the storm came in and the topography of that whole region, but it was definitely unprecedented in its scope and scale.
When I was little, I had never, I watched The Wizard of Oz and I was afraid of tornadoes. I really was. But I don't remember having experienced or heard of one in southern Ontario. I think there was one in Woodstock.
1979,
right.
F4.
Right. Yeah. And then there was the Barrie tornado and the Guelph tornado and the Vaughan tornado just a couple of years ago. But are tornadoes in this area, are there more of them, or are they just being reported more?
You want to take a stab at that?
I think they're being reported more.
Okay.
Everyone has a phone now, so every time there's...
Who's carrying a camera tonight? Show of hands. Who's got a camera on them?
Oh my goodness.
Yeah.
Everybody, right?
Well, almost. I don't.
The other thing is the 24-hour news cycle, so it gets reported on and you hear things, whereas in the past you didn't. And
Right.
So there's not much evidence that the number of tornadoes is changing. There is a little bit of evidence that where they're happening is changing a little bit, but that's still really tentative. So it's a hard one to answer.
And there's more of us looking too.
Yeah.
And we're spread out more.
Yeah. How many tornadoes do you think we get in Ontario in a year? What do you think? Just shout out some numbers. What do you think? 40? 1,000? 10? We get 12 to 20 tornadoes every year here in southern Ontario. And they are typically very weak. They typically happen in the corridors, basically along the 401, from Windsor up through London, towards Barrie, and it has to do with the way the lake breezes converge. You get the hot air heats the sun heats the ground heats up, warms the air, that air wants to rise, and the cooler air comes in off of the Great Lakes, and where they intersect, the air's got nowhere to go but up to form these cumulonimbus clouds. That was just for you. Which then can produce tornadoes. So that's how we get most of our tornadoes here in Ontario.
So it's the topography, really, the geography of that area.
We have a microclimate here in southern Ontario because of we're surrounded by lakes on all sides.
Right.
It also just so happens that corridor along the 401 is pretty highly populated with people who have cell phone cameras and YouTube accounts and Twitter.
So that's why we call it our tornado alley.
We have a little mini tornado alley here.
Yeah.
Not the typical tornado alley that you see in the U.S. from Texas, Oklahoma, Kansas, Nebraska. They see between 800 to 1,200 tornadoes per year. So we are number 2, a distant second. In total, between the prairies and Ontario and the rest of Canada, we get, maybe 60 to 100 on a busy year. The U.S. gets 800 on a slow year. So we're second, but we're a distant second. The U.S. gets 75% of all tornadoes in the world, if I'm not mistaken.
I just heard, though, that Europe has about 240 tornadoes a year on average.
But Europe's not a country.
I know.
I stand by my statistic.
Touché.
But yeah, Europe gets quite a few. England, I think, if I'm not mistaken, England gets more tornadoes per square mile or square kilometer than the U.S. does, because they get a fair number of them, but it's a smaller territory. But they also tend to be very weak. They happen in Italy, Poland, Australia gets them, Argentina, Japan.
Japan has a lot.
South Africa, and here in North America.
Wow. There's news. Yeah. You mentioned, I mentioned glaciers before. I remember about 40 years ago going out west and traveling from Banff to Jasper and there's a place, I don't know if some of you may know this, the Columbia ice field, and you can get close, or you could get close to the
Athabasca Glacier.
Exactly. And when I went there about 40 years ago, there's a parking lot, and you get out of your car and walk across a little bit of gravel, some of the glacial moraine, and you go up and you can feel the meltwater of the glacier and stuff. And then when I went back there 25 years later, and there were all these little markers, and they had markers like 1990 and 1980, 1975, and I didn't know what it was. This sounds like I was being dumb, I guess so, but I didn't know what those markers were. Are they mileage are they what markers are they? And it was years. They were marking where the end of the glacier was at that particular year, and these little white signs, were marching back. And I remember where I had parked my car back in 40 years ago, in the 70s, and the end of the glacier was way the heck. There was a heck of a lot of gravel between where you could park your car and where the end of that glacier was, and it was like, once I realized what those markers were, it was like, oh no.
Yeah, I've never been to Athabasca. Have you guys? Have you been?
No.
Scott?
No, I've never been.
No. Glacier National Park in Montana is running out of glaciers.
Yeah.
They might have to rename the national park.
Well, there's a downer. That's it for me.
But on a brighter note, I got really cool lightning bolts on my socks.
Yeah. Well, let's see, what else can I ask? This is all right. It seems from the science, and I shouldn't say seems, because then that would contradict what Maurice had said. Climate change, for anybody who's willing to keep their eyes and ears open and not deny that their lifestyle might have to change a bit or a lot, climate change seems to be something that we have to deal with. If we were to somehow, magically, reduce the amount of carbon that we continue to pump into the atmosphere, not only from burning of fossil fuels, but from concrete production. You know, China a few years ago produced more concrete in 1 year than all of North America had, or the U.S. had, in a 100-year period. To make things, like to just do all the building that they're doing to make the Three Gorges Dam. And concrete production is a major releaser of carbon dioxide. So, given that this kind of stuff is happening, is there something other than saying, okay, no more fossil fuel burning or whatever, that we can do to really significantly slow it down? Because the 2-degree rise, I think we're going to go beyond that. I think we're going to get close to 4 degrees, which is pretty scary. Can we do this? Go ahead, say something, please. Help us.
Okay, so the question is basically, what can we do to all methods? Not only change the way we get our energy, but also our practices and maybe even removing carbon dioxide from the air? Is that what you're talking about, or just the energy factors?
What's a simple thing that we can do tomorrow to help?
Reduce the amount of electricity that you use in your house. That could be just make sure that you're not walking out of a room and leaving, that you know you're not going back into and leaving the light on. That's even unplug your toaster, unplug some of your appliances when you're not using them. Put a power bar on your television and your VCR, or not VCR, but your DVD player.
VCR?
VCR. Oh.
Is anyone?
Well, showing my age a little bit there. Yeah.
I've heard of one of those.
Yeah,
I think
yeah.
my mom had one.
Or your record player.
The good thing is I don't have one anymore. Yeah, but and then
It's next to your 8-track player.
Yes, exactly. That's my hi-fi. And turn that off at night, because the television and the other electronics are always in standby mode. So even they're drawing electricity even when they're turned off from your perspective, when you hit the power button on your remote. Don't drive as much. Even if you have to drive, it's a matter of keep your car properly tuned, keep your tires properly inflated, just to make sure that your car runs at peak efficiency. If you can switch to an electric car, I mean, Teslas are looking very nice these days. Please do. I mean, even the Leaf and so forth. But the simple things are just buy locally for any product, especially food, because shipping is a huge source of carbon dioxide pollution. Reduce electricity use, reduce your travel in your car if possible. Use public transportation as much as possible. Just if you have a whole bunch of errands that you have to run, don't go one at a time throughout the week. Bundle them all together, do them all at once. That sort of thing. Those are the simplest things you can do. But that's really not going to do it these days. We're looking at it these days, and it's just we're pushing things far too quickly. We're releasing far too much of this carbon dioxide that's been sequestered in the ground for millions of years. When they talk about the carbon cycle, and you'll hear people talk that they're on the contrarian side, saying, well, carbon dioxide goes up and down all the time, and it's plant food and all these other claims. That's the normal amount of carbon dioxide in the atmosphere, the 0.04% of our atmosphere, that keeps our planet normally warm, probably about 30 to 40 degrees warmer than it would be, and it gives us this nice, stable climate that allows agriculture and allowed its civilization to develop, basically. The problem is that the carbon dioxide we're releasing right now is absolutely no part of that. That is stuff that's been buried under the ground, sequestered away for at least, 65 million years. since the dinosaurs went extinct.
And before.
And before.
And before.
And we're digging that up at record rates and burning it off at record rates, so that when you look at a graph and it leisurely meanders along, ticking up and down for 800,000 years of the current record, and then it shoots up half again as high in the past 150 years. So we've added 40, I believe it's 46% more carbon dioxide to our atmosphere. When you're dealing with 0.04% of the atmosphere, that may seem like a small amount, but it's the effect. The planet has been used to having just that tiny bit, the 280 parts per million, for hundreds of thousands, millions of years. Now it's being pushed half again as high, and it's just too fast for the planet to adapt. Nature is going to suffer for that. And so now we're going to have to look into, we have to stop emitting completely within maybe a decade, hopefully, just to keep things from getting a lot worse. The thing is that we've still released enough that we're still going to see effects. Even if we shut every fossil fuel burning object that we have, every power plant, every car, every plane, everything that burns fossil fuels, if we shut it all down tomorrow, we would still have to deal with climate change. It's inevitable, it's unavoidable right now. The key right now is to avoid the worst effects by dialing back in an extreme way what we're emitting out. So we may actually have to commit to projects that will remove at least part of what we've put into the atmosphere. Carbon sequestration is what they call it. So scientists will come up with ways of drawing the carbon dioxide right out of the atmosphere and solidifying it, putting it into rock. The only thing is they'll have to, moderate that so they don't draw it all out. We need some of it to keep the planet moderately warm. But we're going to have to do something about that amount that we've already emitted to pull it back. Otherwise, things are still going to get worse. The thing we have to avoid by switching to clean energy is to avoid burning it all, and that's going to cause a climate disaster.